Hi, I'm Dr. Jim Zoval, a professor of chemistry at Saddleback College. You're about to watch one of my video lectures. If you like this lecture, you can get the entire Allied Health General Organic and Biochemistry course from the website address you see on the screen right now. Be sure to type the underscore between VOD and pages in this address. Enjoy the video. We're finally ready to discuss chemical compounds. All this background in Chapter 3 got us ready to do this. Most stuff around us doesn't exist as in its elemental form as just only one element or one type of element. Most things exist as a compound, more than one type of element combined. Here's a definition of compounds. Matter that is constructed from two or more chemically combined elements. I'm going to shut up for a minute while you guys write that down. For a particular compound, that compound has the same proportion of the same elements, no matter where we find it. For example, water. Whether you find water in a pond that's really muddy or a beautiful place like Lake Tahoe, or they finding water on Mars now, whether it's in the gas phase, the liquid phase, or the solid phase, it will always have the same proportion of the same elements, which are, what's the elements and what's the proportions? You guys know this. What's hydrogen, oxygen, what's the ratio? One oxygen, right? That's how compounds exist. Another example. The major component of table salt is sodium chloride. And sodium chloride, no matter where they mine it in the United States, they mine it in the Soviet Union, it will always have one sodium for every one chloride. That's the nature of chemical bonding. If it had a different ratio, it would be something else. For example, a molecule that has a formula H2O2 is not water, that's hydrogen peroxide. You guys do not know, you guys probably don't know who that is because you guys are young. You know, really popular when I was in high school. Now this song is appropriate because of our definition of chemistry. Chemistry is the study of matter and the changes it undergoes. It could have physical change or chemical change. That's what chemistry is about. Change. Chemical change or physical change. We discussed briefly physical changes. In physical changes, you'd never change to a different substance. You might change the phase. You might go from a gas to a liquid or a freeze liquid to solid. That's a physical change. Okay? And we talked about physical properties, boiling points, melting points. What temperature does it boil at? What temperature does it melt at? Color, whether it's malleable, you could pound it into sheets like you can metals, or its color. Those are physical properties. Chemical change involves changing the way things are chemically combined. Now I'm going to go back here and let's look at our definition of compounds. Matter is constructed of two or more chemically combined elements. The rest of this lecture for Chapter 3 talks about what we mean by chemically combined elements. Chemical change. Matter is changed to a new substance. That's how you know you did a chemical change, not a physical change. Think about physical change. Boiling water. We're just going from water molecules in the liquid phase to water molecules in the gas phase. We're not making a new substance. We started with H2O and we ended with H2O. That's not a chemical change. In a chemical change, a new substance is formed. It's a process where a new substance is formed. Why is that? Why is it a new substance? By definition, it's a new substance when chemical bonds are made, broken, and sometimes both. And we have a whole chapter on chemical reactions. That'll be chapter 6. We want to delve a little bit more into matter. This is a little preview of chemical change. We discussed physical properties such as color, boiling point. We could also talk about chemical properties, and that chemical property would be the ability and the rate of a substance to be changed into a new substance. Sometimes the rate. Sometimes it happens very fast, like an explosion, a firework, fast chemical change. Other times it happens very slow, so slow it's hard to even observe, like the rusting of a nail. An example of chemical change, if you start with a car that was metal like iron, very slowly there was a chemical reaction between the iron and the oxygen to make new bonds, to form a chemical compound called iron oxide or rust. Now let's talk about chemical bonding. I'm going to give you a couple examples of this, and then we'll look at how it happens in great detail. So we have isolated atoms. They could come together to form a compound. So chemical bonds, what are they? They're electrical attractive forces that hold atoms together. Everything we study in this class comes back to this interaction between positive and negative, and repulsion between negative, negative, and positive, positive. Some examples of attractive forces that you might be more familiar with.
Ooh, baby, let's stay together.
Stay together, right? I love this song. The King, the Reverend Al Green. If these dogs are like my dogs, and I didn't have a force holding them together, the force is called tension. It's tension that they're crazy as hell. That Joel, I gotta edit that out. Can you say hell on school bit? Okay, they're crazy as hell. They'd go everywhere. The tension in the rope holds them together. You can't feel the force pulling your fingers back together. That's a mechanical force, elasticity. If those of us who surf, we need a force holding our board to us, because if we fall, which I do a lot, the wave takes the board all the way into shore. And if you're surfing somewhere like San Onofre or Waikiki, it's a long swim in. We're going to look at 2 types of chemical bonding. In nature, there's only 3 types of chemical bonding. One of the ones that we're not going to talk about today is called metallic bonding. What holds these aluminum atoms together? It's very simple. It'll just take a few minutes. We'll see that late in chapter 5. We're going to look at the other 2 types of chemical bonding that occur in nature. Those 2 types are ionic bonding Guess what ionic bonding involves? Ions, right? And something called covalent bonding. I want to give a brief introduction on each of these, and then I'll go into details of covalent bonding, and we'll talk about those forces, and then we'll learn how to name covalent compounds, and then we'll go to ionic bonding. I'll give a detailed description of ionic bonding, and then we'll learn how to name ionic compounds. Hi, I'm Dr. Jim Zoval. If you like this video and you'd like to get the entire course or just some of the chapters on video, I have the entire course in video lectures at the website you see on the screen right now. They're available on demand. The period of the rental is for a full year, so you'll have this video through the entire course. You could watch it as many times as you want, whenever you want. Happy studies.